Hello guys, my name is Juan Felipe Suelta, and today I'm going to talk to you about op-amps, also known as operational amplifiers. These are electronic devices that amplify the difference in voltage among both entrances. This is an integrated circuit that's used a lot in analog electronics. It can be used, for example, to use on mathematical operations like sum, rest, mm, taking the promedium, also in derivation and integration, and you could say in a lot of other fields. It could also be used as a buffer to, for example, filter a signal and make it cleaner, a lot better, and less with imperfections, you could say. Another kind of configuration, it can be used, as its name suggests, amplify a signal. So, for example, you have, let's say, I don't know, 1 volt signal. It can, for example, amplify to a 5 volt. This is commonly used, you could say, among, for example, microphones that takes a small signal and later on it amplifies it towards the speakers so that it can be louder. The op-amps have two terminals in entrance, a negative, or also known as inversor, and a positive, or also known as non-inversor. There's also two different pins that we're going to see later on that are used for supplying voltage to the amplifier, and that's one thing. This isn't to create energy. It uses an outside source to amplify a signal. So rather than creating, it uses to make bigger data per se, you could say. So that's the easy introduction. Following on, we're going to talk about Proteus that we're going to use to simulate the different configurations that it can have. Okay, so now with this in mind, we're going to open Proteus so that we could do our simulation. So let's share it. So here we have Proteus. First of all, we're going to open what our resources that we're going to use, which is going to be the LM741. That's going to be our operational amplifier. So let's keep it here. We're also going to be needing a source, a B source. This we're going to use the last one. That's a DC voltage source. So let's put it right here. We're going to need both of these. So this. Later on, we're going to need resistors. Sorry, resist like that. We're going to put it here. So now for our configuration that we're going to use on all simulations, we're going to do this. We're going to need a ground that we're going to connect like this. We're going to also need two inputs that we're going to put here and here, and two outputs that are going to be here and here. This one going to connect to VCC positive, and this one to VSS negative. We're going to connect this one to this one. Oops, sorry. We're going to connect this one to this one. This input, we're going to name it beam. This one's going to be also beam. We're going to name this one A, and this one's also going to be A. So what we did here is that we gave energy towards this amplifier. Also, we're going to configure this to 15 volts and 15 volts. This can be any value, and now we're going giving energy towards the amplifier. This one's giving minus 15 VC, minus 15 volts towards BSS, minus BSS, and this one's giving a 15 volts towards VCC. Why are we doing this? Because an amplifier is going to need that, and also to determine the range of amplitude that it's going to work. If we increment both of these values, sorry, then the amplitude that it can go is going to be higher, and the same if we lower, it's going to be lower. So that's it for this program. So now we're going to go towards our first configuration, that's the non-inversor. Here we have it, the following diagram, and also the equation. So for this one, we're going to need the following components: two resistance or amplifier, and a source that's going to be the input. What's important about this one is that the value that it gives is towards the same, you could say, value in the way that the same charge. Like if it enters positive, then it's out positive. If it enters negative, it goes towards negative. So that's important about this configuration. What could we say about this? Number one, if we want to know the exit voltage, then we would use R2 or R1 plus 1. This is our amplitude. This one's amplitude by V1 equals V out. So let's say in one case, let's give it 1K over 1K, and this one a source of 2 volts. Then we would have the following: 2 volts multiplied by 1K, 1K plus 1, cancel units. So this could be 2, and 2 plus 2 equals 4. So the exit voltage in this case, it would be 4. Or let's say now, if we, for example, change this value for 2K, so R2 would be 2K. So then this value would be, in this case, 3 by 3 would be 6 volts. So now with this information in mind, let's check towards our program. So here we have our configuration. As you can see, it's already been done, and nothing that we haven't thought about. However, we're going to change the values that we say. So let's try first of all 1K over R2, and this would be R1 1K, and our source of 2 volts. Important to know that in this page, in virtual instruments mode, we find our voltmeter that we're going to put right now. Forgot to mention that. And we're going to connect it to ground like that. So our first 4 volts compared to the ones that we said, so we could say it was a success. And now let's try the second configuration. That was R2 would be 2K, R1 would be 1K, and taking into account that we should be expecting 6 volts. And as we can see, we get 6 volts. Now, what else could we do? For example, minus 2 volts. Minus 2 volts. What would happen? Then we should be expecting minus 6 volts. However, in this case, the program doesn't take units, but it's important to know that. All right, so now let's go to the second configuration. That's the subtraction one. First of all, this one's composed of 4 resistance. This one and this one is the same, and this one and this one is the same. Important to keep that in mind. So this configuration has 2 purposes. Number one, as the name says, it can subtract 2 voltages. This one that goes towards the non-inversor terminal, and this one that goes towards the inversor terminal, as we see here. However, we can also use it as an amplifier because this element. So let's say, for example, we only want the kind of step that just subtracts. So R2 and R1 would be the same. So we could say 1K, 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 and 1K. So 1K over 1K minus, let's say the positive voltage is 3 volts and 1 volt. So 3 volts minus 1 volt, this would give us 2 volts in this case, in this configuration. But also, let's do, for example, this could be 3K. 3K and 3K or 1K. And let's keep the same values and see what happens. 1 volt. So if we cancel this and this, we would get 3 by 2 volts. So it would give us 6 volts. So let's try it over the following program, Proteus, and check if we are right or if we're wrong. Now here we have the following circuit, and let's replace values. So we said this one would be 3 volts, this one would be 1 volt, and in this case, R2, let's keep the first case, 1K, and 1K, and 1K, and 1K. Now, if we simulate this, we're going to get 2 volts that we already said at the beginning. So in that part, it's all right. However, let's change R2 in this case, so 2K and 2K. So what would be getting? 4 volts, which is also expected. However, I committed the mistake that this could be 3K. So let's replace this very quickly. 3K and 3K would be 6 volts. Now it gives, I committed a mistake, so sorry. So as we can see, this configuration can work both as an amplifier and also as a subtractor. Depends on what you need. You replace the resistance according to your needs. Okay, so now here we have our last configuration. That's the sum, and you could say it can take the average about 3 voltages. How it works? So first of all, it's important to know that whatever result it comes in, it's going to be inversed. So let's say all of these are 5 volts, and so we would be expecting minus 5 volts. It's important to keep in mind that. So how this works? Number one, the easy way would be, for example, put this 1K, 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 and 1K. So all of them are the same. That would mean this, and this one would cancel, and that would mean it would be just the sum between B1, B2, and B3, like the following. If we did that, it would be 1K over 1K, and B1 plus 1K, 1K, and 2 plus 1K, 1K, then 3. So it would mean this one be 1, 1, and 1, so it would be plus 2 plus 3. And this would be multiplied by minus. So if we replace values, for example, this would be, let's say, I don't know, 4 volts, 3 volts, 5 volts. It would be 7, 5, 7, 8, 9. It would be minus 12 volts, excuse me, in that case. However, if we would wish, for example, take a medium, for example, an average of grades, for example, I don't know, the semester, and it would be 30, 30, and 40 accordingly. We could do, for example, 1K over 3K, and the grade, let's say the same, so it would be 4 plus 1K over 3K by 3 plus 1K over 4K by 4 by 5, excuse me. And we would be expectingly accordingly 1 over 3 by 4 plus 1 over 3 by 3 plus times and then by 5, we would be expecting a voltage around minus 3.58. So with that in mind, let's go to Proteus and check if we're doing this all right or not. So let's share it. So let's try our first case where it's 12 volts. As we can see, it's already the same value. So now we only need to replace 4 volts. This would be 3 volts, and this would be 5. So if we simulate, there it is, minus 12 volts. So in that regard, we know we're right. However, we're going to try the second wave. So this could, let's just change it to let's say 30K. Excuse me. Yes, 30K. 30K, 30K, 40K. I don't know, this would be 10K. So let's check out. And there is minus 3.58 volts. So that's important to know. Remember polarity, maximum values, and overall check everything that you can do in this program. For example, let's replace this by 10, 20, and let's say 30. You would say, oh my God, it's going to give a big number. However, it's just limited by minus 13.9, mainly because of this voltage that's been provided by here. So keep that in mind because it can go over 15 or minus 15. It could multiply by, let's say, 1,000, but it wouldn't work. So keep that in mind. I hope this tutorial helped you and thank you for listening. Please subscribe.